Alright, so today we are going to look at the last section in Module 6. This one is 6.8, comparing models. So we couldn't completely abandon Module 6. We had a few more sections. I just cut out all of the unnecessary ones, but this one is pretty important. This is honestly a section that we've done before. You'll kind of see how it kind of goes along. If you remember your quiz that you took, actually a lot of people did very well on the quiz, so that was a good job. Very proud of the grades that we had on those last quizzes that we took. But there was a problem that we worked that's going to be very similar to what we did. We're going to kind of expand on that a little bit. This also pops up again in Module 8 when we get into finance. Whenever we get there, we're still trying to figure some stuff out and how we're going to teach these next few weeks. But right now we are planning we'll get to that finance section eventually. But focusing on this, we'll go ahead and kind of jump into everything that we have here. If you have your workbook, by chance, we're on page 50. If you're like probably everybody else, or probably everyone in all my classes, your workbook is in my classroom, in the back of my classroom. So I put a blank sheet or blank PDF of this section. You can print that out and follow along. If you want to follow along on a separate sheet of paper, whatever is most comfortable for you, doesn't make a difference to me. At the end of the section, I'm going to have you work a problem, submit that in to me. I'll kind of explain that when we get there. You can do that on a separate sheet of paper, or you can do it on a printed version, whatever. So let's go ahead and look at this section. So we're going to look at this little paragraph right here, setting everything up. It tells us that Derek is trying to save money for a down payment on a used car. His parents have said that they will help him put money aside. They're going to pay 10% interest of the money that he accumulates each month. And right now he has saved $200. So he's got $200 in the bank. His parents are going to come along and put 10% interest, figure out what that is, add that into it, and they're just going to do that each month. Derek himself isn't putting any money in the bank. He just has that $200, and that 10% interest is building off of that. So if we look at number 1, it says that he doesn't add money to his savings. So recursive and the explicit function. So we should be familiar with those, especially based off the project that we just did, and wants to know how much he will accumulate with only the addition of his the interest from his parents. So before we completely dive into this problem, one thing that we need to be on the same page with, this is going to be an explicit function. So if you remember that was in 6.4 when we had the tennis ball, we dropped it. That was an example of exponential decay, because every time we dropped the ball didn't go further up past my hand. It kept getting closer and closer to the ground. So the distance there got smaller, so that's an example of decay. In this situation is the opposite. We have exponential growth. In this case, Derek's not going to have less than $200 in his bank if we keep adding interest to it. So if you remember how we do that, we're going to take this 10%, change that into a decimal, so that's going to be 0.1. And then we're going to add 1 to this, the whole number 1, because this is an explicit function. This is a plus sign. So this is going to equal 1.1. So this is what we're going to use in our explicit and recursive function, and so it represents growth instead of decay. So before we write out these functions, I'm going to put 2 variables here. So N is going to represent the number of months, so that's going to be a very important component to this. We need to figure out how long it's going to take them to reach whatever it is. And then I'm going to use T as his total savings. So this is the amount of money that he has accumulated through his parents putting interest into his bank account. So to get to the actual functions, we're going to start with the recursive rule. That's probably the one that we are most familiar with, and one that we kind of like more than the recursive rule. So T is going to be on the outside because we need to figure out what his total savings are. The way we're going to write our explicit is going to be 200. I'm actually going to put an X. I'm going to use that to represent multiplies. 1.1, a lot of dots in there, don't want to get confused. And then this N is going to go up here. That's going to be squared with that interest that we have. So we have T equals 200 times 1.1 N squared. Or I'm sorry, to the nth power. So let's get to the recursive rule. So if you remember the recursive rule, it's 2 things that we need. We're going to have our starting point and then the function that it builds off of from there. So in this situation, we have t of 0. So t represents our total savings. 0 is the amount of months that he saved. So before he does anything, the amount of money that he has is $200. So that 200 is going to go here. The second part of that is going to be the function itself. So we're going to have tn plus 1 equals tn, and then again, to express multiplying, I'm going to put an x right here, 1.1. So whatever that number is, we're going to constantly multiply that times our exponential growth of 1.1. So that's going to be both of our functions there, explicit, recursive. They should look familiar to what we did in a few weeks ago, if we can remember that far back. So this so far, not really learning anything new. So let's take a look at number 2, get into a problem of this. So it wants to know how long it will take Derek to save at least $2,000 on a down payment with only the additions to his parents' interest payment. It wants us to explain our reasoning as well. So easiest way to do this one, we're going to take the explicit. So our t equals 200 times 1.1 to the nth power. Now I'm going to take the t and the n, I'm going to change this to y and x. That's a little more we're familiar with, and when we plug it into our calculator, it's going to help there. I put these in right here just to know what these numbers represent. I think that's important for the context of a problem. We can move it down to our xy. So the way that we do this, if you remember, we're going to plug this into our calculator. So if you have an actual calculator, that's yours and not something that you borrow from school, fantastic. If not, the email sent yesterday or whenever this gets posted that has all of the those apps. Calculator 84 is really good for the iPhone. I forgot the one that was for the Android. Of course, you can use online. You can download the TSI 84. You're going to go to y equals and type this function in to your y equals, so 200 times 1.1 to the x power. And then you're going to go and look at the table. And then you're going to get your final answer there. So when you do it, I'm going to show you after get the answer here. So if you look through, you're going to get 25 months, so a little over 2 years. So if he doesn't add anything to it and it gets constantly add, it's going to be 25 months before he has at least $2,000. Okay, just to show you where I got that number from, I just typed in calculator 84. This was the first website that popped up. So get to where we can draw. So here is my function right here. I just typed that in, y equals 200 times 1.1 to the x power. So I have that typed in there. I am going to click on the table. So here's our function here. Hit create table, and then it has a lot of numbers for us here. So if we look at this table, we're focusing on the y's. We need the y's to equal 2,000. So if we follow all of these y's, if you'll see, we don't really have one. This is the last one that we have right here. That doesn't have what we need. So we're going to change our x starting point. So I'm going to come around here and do that. So I'm going to say let's start at 10, and then if we look at this, if we start at 10, we're looking for 2,000. Here is a number right here, the first number that's past 2,000, and then there's your answer right there of 25 months. So if you did this in your calculator, show you got the same thing, did it online, whatever. Whichever method we use, 25 is going to be our final answer for number 2. Alright, so let's look at the chart that we have on number 3. So we'll kind of go through this chart. Should make some pretty good sense to us. So it says to speed up the time needed to save the $2,000, he decides to take jobs on in his community, and he'll add 10% interest, or his parents will still add that 10% interest as promised. So he's adding $10 along to his bank account each month. We're going to see how that affects his bank account, if it's going to be more money or how much more it's going to be. So we're only focusing on the first 6 months right here. So we're still starting out with our $2,000. So the months right here, this is going to represent N, like I said. The dollars over here, that's his total. That's going to represent T. So he starts out with $200. So after that first month, he's going to have that $200, and it's going to be still multiplied by that same exponential growth function that we came up with of 1.1. So that's the interest that's going to get paid there. Now what's different this time is this. He's adding $10 per month, or adding $50 per month. So we're going to have plus 50 right here. So this is just something we got to plug into our calculator. 200 times 1.1, and then we're going to add $50 to that. So when you do that, you're going to get $270. Easy enough. So now when we get into that second month, we got to be careful. So by that time he's in the second month, the amount of money that's in his bank account isn't going to be $200. It's going to be this one right here, the 270. So he's got 270 in his bank account. We're going to multiply that times 1.1, because his parents are still adding that 10% each time. And remember, he picked up that job, so we're still adding $50 to it. So we plug all of that into our calculator and get $347 now. So when we get to that third month, again, the amount of money in his bank account is going to be from the month before. So hopefully we kind of see the pattern that's going to be picked up here. It's going to be $347. We're going to multiply that times 1.1, add that 50 to it, and we're going to get $431.70. Okay, I just added in the rest of these. Didn't want to waste a whole lot of time explaining this one, and I think a lot of us can pick up on the pattern that's going on here. So after 6 months, he is going to have $740.09. So we're going to look at 4 and 5. I'm probably going to split this into 2 videos because we're pushing 12 minutes right now. So we'll just do this one page as one video. We'll flip it over, look at the back, and then that'll be the second part of this. Anyway, let's look at number 4. It wants us to write a recursive role with the function with the new change in the scenario. So of course this time we're adding $50 a month. So our recursive rule, we're still going to have our original, or our starting point. It's still this $200. So T of N is going to be $200. Nothing new there. What is going to be new is going to be the second part of this function. So I'm actually going to give myself a little bit more room here. So I'm going to erase this and move it over here, just so we can have enough room for the second part of it. So we're going to have Tn plus 1 and then T of N. So after we have that, we're still multiplying it. So if we look at the process, we're just multiplying it times this 1.1 and then adding 50. So if we look at the process, the only thing that's different in each of these columns that I have is this, and this. Everything else is the exact same. This times our 1.1 plus 50. So I have that represented there. So there's your recursive rule. Now number 5, really good question. I like this one a lot. It says, why can't we do an explicit rule? So explicit rule is the one that we really like, and it's asking us why we can't use an explicit rule here. Well, when we use the explicit rule, we have a fixed number that represents our x, or represents part of our function. If you look at this, we don't have that same number. This number right here is constantly changing. These numbers are changing here. I don't want to do too much of that. Kind of covers it up. But because it's constantly changing, we can't have an explicit rule to go with it. If you want to think of it, this is kind of like, in a way, like the slope. The slope's constantly changing here. So we're not going to have an explicit here because it doesn't allow us to have that. So I don't have a whole lot of room to put this, but basically the explicit rule, or the explicit function, it doesn't allow the ability to add that constant, that new dollar amount there. So it doesn't allow you to use a new dollar amount in this situation. So if you remember, the explicit one that we had in number 1 was this t equals 200 times 1.1 to n. Well, this 200, if you notice, it's not constantly n over here. We don't see 200 right here in the second month. We're not using 200. Same here, same here, same here, and same here. So the explicit function doesn't allow us to replace this 200 each time. Only the recursive rule allows us to do that. So I've always got questions, what's the point of the recursive rule? This is really where it comes into use. So this is the first page. Like I said, the next video is going to have page 51, and we'll just continue on from there.